3.4, day 2. We're still on linear programming. Essential question: how do I solve linear programming problems? Please write that down. Well, here we go. We have an example right in front of us. A bookstore manager is purchasing new bookcases. The store needs 320 feet of shelf space. Bookcase A provides 32 feet of shelf space and costs $200. Bookcase B provides 16 feet of shelf space and costs $125. Because of space restrictions, the store has room for at most. That's an important word. A couple of words here. Like this. At most 8 of bookcase A and 12 of bookcase B. How many of each type of bookcase should the manager purchase to minimize the cost? All right, so what are we doing here? We are minimizing the cost. So sometimes what's going to happen in these word problems, there are times you're going to be given more information than you need for the constraints. So then we look to see the question being asked: how many of each type of bookcase should the manager purchase to minimize the cost? So with these linear programming problems, we're either maximizing something or minimizing something. And that's something that we're minimizing here is cost, which means that the $200 and the $125 are not going to go into the constraints. They are going to end up going into the objective function when we get there. All right, so that's what you kind of look for to know what goes into the constraints. The question being asked, again, whatever we're minimizing or maximizing is not going into the constraints. So X is bookcase A, Y is bookcase B. I highlighted some things ahead of time. So number 1, I told you in the last video that there are 2 constraints that are automatic on these linear programming problems because you can't have a negative number of bookcases. So that's those 2. Now I have a lot of things going on, but let's look down here at that word at most. It says, because of space restrictions, the store has room for at most 8 of bookcase A and 12 of bookcase B. So that means that bookcase A, it has to be X less than or equal to 8 because I can only make 8 and not any more. At most, that's what we use as an inequality. Y looks like that. If it would have said at least, then the alligator would have been eating the X and the Y. But when it says it only has room for 8, then that's the maximum. So the alligator has to eat the maximum, which is the 8, and the alligator has to eat the 12. All right. Well, let's see here. We've used 8, we've used 12. We already said we're not using the money until we get to the objective function. So I'm left with the 32 and the 16. I'm trying to think how to use that. Well, bookcase A provides 32 feet of shelf space, and bookcase B provides 16 feet of shelf space. And we have 32 feet of shelf space available, or the store needs 300 and I said 32, I meant 320 feet of shelf space. Well, that means we need that much shelf space, but could we have more than that available? We could. So we're going to write this out as 32 is going with A. So that's going to be 32x plus the 16 is going with B. That's going to be 16y greater than or equal to. What the 32 and the 16 refer to is the shelf space. The store needs 320. So that's why the alligator is facing the 32x plus 16y, because the lowest we can go is 320. No lower than that. Could we have more than that? We could. There's our constraints. All right, I'm just double checking everything. Okay. So now we're going to graph the feasible region. Well, I have to write all of our constraints down again. We have x greater than or equal to 0. We have y greater than or equal to 0. We had x less than or equal to 8. We had y less than or equal to 12. And let's do one more color here. We'll do pink, which is 32x plus 16y is greater than or equal to 320. All right. So let's see. I think what we're going to do is count on this one. I'm going to count up by twos. 2, 4, 6, 8, 10, 12, 16, 18, and 20. And the same thing here. 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. All right. And again, notice that I have my graph set up this way because x is greater than or equal to 0 and y is greater than or equal to 0. So we can't have any negative y values and we can't have negative x values. So what I can do right now is I know, let's do my straight line. Well, I already know that x, this is, oh, I can't do that though, because I'm going to cover everything up. So instead, we know that, oh, try that again. Get a pen. That's what I'm trying to get here. There we go. I know that this line right here, there we go, is that line. So like that. I know that this line right here is the y equals 0 line. I know that x equals 8 or x less than or equal to 8. That's going to be a vertical line at 8 because x is always 8. So that's going to go like this. I'm trying to make it as straight as possible. Okay, so that's 8. And this line, the y equals 12, that's a horizontal line at 12. There we go. So the last thing we have to do is graph the pink line. So before we can graph the pink line, I think the easiest way to do this is, again, we're going to find X-intercepts and Y-intercepts. So I don't want, there we go. There we go. And there we go. Okay, so the X-intercept means I'm going to set Y equal to 0. So we're going to do this right now. And I'm just going to, remember, just going to use an equation. I'm not worried about shading right now. And divide both sides by 32. Whoops. Okay, 32. And we get x is equal to 10. Okay. I feel like I messed up on something here. I'm just double checking everything here. 32x, 320. Yeah. Okay. So our first point then is going to be 10, 0. Now I'm going to find with the same line, I'm going to find the y-intercept. So I have to set x equal to 0. So 32, 20. And that's just 16y equals 320. Divide by 16. We get y is equal to 20. Okay, it's 20. So it's 0, 20 is my next point. So let's graph those right now. We have the point 10, 0, and we have the point 0, 20. And I'm going to get out my ruler here. And I'm going to connect those. There we go. Okay, right there, right there. There we go. Now we have to figure out where we are shading. Well, I know that with x greater than or equal to 0, I'm shading this way. Y greater than or equal to 0, I know I'm shading this way. X less than or equal to 8, that's this vertical line, smaller means that way. So right now we're all kind of right in here. And y less than or equal to 12 is below. So let's think about this. Where are we all overlapping? We have the red going this way, the black going down, the green going to the left, and the blue going up. So where they all overlap is going to be right in here. Okay. So now the next job is, remember, we need to find our vertices. So we have a vertex here, we have a vertex here, and we have a vertex here. Might be able to tell what those vertices are just by looking at the graph. This one looks like it's over 4 up 12, 4, 12. This one, it looks like it's over 8 up 12. And this one looks like it's over 8 up 4. Perfect. So we found all of our vertices, 1, 2, 3. There are 3 vertices, 3 corners. And so now we're going to write those vertices down right here. So we have 4, 12, 8, 12, and 8, 4. So we're going to finish the rest of this in class. And here are your video questions.